We have Unit 3, Algebra 1, review for the test, Problem 9. Change to slope-intercept form and graph. Our first example is 3x plus 2y equals 6. Slope-intercept form is the form in which y equals mx plus b. M is the slope, b is the y-intercept. It's one of those things you just have to memorize. You have to learn it. Don't forget it. You will need it forever. Okay, if we want y all by itself, the first thing I'm going to do is subtract 3x from each side. That gives me 3x minus 3x is 0. So I have plus 2y equals negative 3x plus 6. Can I combine these terms? I cannot. There is an x here, 3 multiplied times some number. And 6 has no x. No way to combine these. Now if 2y equals this, what does 1y equal? I divide every term by 2. 2y divided by 2 equals negative 3x divided by 2 plus 6 divided by 2. What does that get me? That gets me this. 2 divided by 2 is 1y equals negative 3x over 2 plus 6 divided by 2 is 3. Okay, now that I have my equation in slope-intercept form, I can graph it. I begin with the y-intercept, which is, in this case, positive 3. Up 1 when x is 0, y is 3. 1, 2, 3. Now my slope is negative 3 over 2. Let me see whether I can show you all of this at the same time. There, that looks pretty good. Okay, my y-intercept is 3. When x is 0, 0 times anything becomes 0, plus 3. Now, my slope is negative 3 over 2. So I go down negative 1, negative 2, negative 3, and then over 2. I now have a line I can graph. This is a function. It is a continuous function. It slants down to the right. Y equals negative 3x over 2 plus 3. Okay, do we have the hang of it yet? Let's try another one. X minus y equals 1. I add y to both sides. X minus y equals 1. If I add y to both sides, I get negative y plus y is 0. I get x equals y plus 1. But I want y by itself. So I subtract 1 from each side. That gives me negative 1 plus x equals y. But, you know, I just like to read it always the same way. So I am going to rewrite this as y equals x minus 1. Now that I have it in slope-intercept form, I can graph it. But wait, what is my slope here? There's no number. What do I do about that? Well, there is a number, and the number is 1. But mathematicians are efficient. We don't write anything we don't have to write. And we just understand that if there is a single variable there, that we mean one of them. Just like here we mean 1y, here we have 1x. Moving right along, if our equation is y equals x minus 1, then my y-intercept, if x is 0, 0 minus 1 is negative 1. My slope is positive 1, so I can go up 1 and over 1. I could go up 2 and over 2. I could go up 3 and over 3. Really doesn't matter. The slope is 1. For every change in y, x goes up by 1. In the same way, for every change in x, y goes up by 1. And there is our graph. Third example. Third example. For x minus 3y equals 9, I want y all by itself, so I think I shall subtract 4x from each side. That is going to give me negative 3y equals negative 4x plus 9. Can I combine these terms? Nope. Same reason I couldn't combine them before. If negative 3y equals this, what does 1y equal? Well, what I must do is divide every term by negative 3. Negative 3y divided by negative 3 equals negative 4x divided by negative 3 plus 9 divided by negative 3. Negative 3 divided by negative 3 is what? All together now, it's 1. Y equals 4 over 3 times x minus 3. What's my slope? This is my slope. What's my y-intercept? That's my y-intercept. When x is 0, that's the value of y. That's my output. So, I can graph this quite easily. My y-intercept is negative 3, negative 1, negative 2, negative 3. My slope is up 4. 1, 2, 3, 4. 1, 2, 3. How many points make a line? 2. Once I have 2 points, I can draw a line. There you go. That is problem 9.